Hi everyone, I'm Ahmad Gad from PTech. In this lecture, I will start to talking about one of the very important part in many equivalence exams all over the world, which is the pharmaceutical calculation. Many exams contain many types of calculation problems. So in this lecture, I will show some types of calculation problems, which is dilution and mixing, and show how to deal with those problems with a simple and smart way uh, to reserve our time and to solve those problems very easily and don't consume our times in the exam. Now we will start with the main section of this lecture, which is dilution, and we will see now how we will deal with this type of questions or this type of problems and how to solve it very easily. Firstly, we must know the dilution means. Dilution here is a formation of a new concentrated or new concentration of the solution from other stock solution. The stock solution with higher concentration and the new solution will be with lower concentration. So we add a diluent to dilute the solution or the stock solution. The formula here we use in all problems is concentration multiplied by volume before dilution must be equal the concentration multiplied by volume after the dilution. So here CB, it means concentration before dilution, CA concentration after dilution, and VB volume before dilution, VA volume after dilution. But there is a very important thing. The units that be used must be the same units in both sides of this equation. If we use the concentration unit by milligram per milli, the other side must be milligram per milli. If the concentration by percentage, the other side must be per percentage. Also, the volume must be the same unit, must be of the same unit in both sides. If we use liter, the other side must be with liter, and so on. Let us start with some example and see how to deal with those types of problems. The example number 1, he said if 500 milli of 15% volume per volume solution is diluted to 1500 milli, what is the resultant percent strength? This type is a direct question. To solve this type, firstly, we should know the concentration before, the concentration after, the volume before and volume after, and which one of these is needed. Here, the concentration before is 15% volume per volume. The concentration after is needed. And the volume before is 500 milli and volume after is 1500 milli. The second step is the check of units. If there are the same units in the both side of equation, then start to solve the problem directly. If there is a difference in units, we must convert the units to be the same. Here, as I said, it is a direct question and the units are the same in both sides. Also, the needed concentration with the same units of the given concentration before. So we use the formula as said before, the concentration multiplied by volume before equal the concentration multiplied by volume after, and calculate the concentration after which is needed. Example number 2. How much methylene blue is needed to make 480 milli of 1 in 50,000 solution? Here in this example, the first step is knowing what is the meaning of 1 in 50,000 solution. It is 1 gram in 50,000 milli. 1 gram of the solute in 50,000 milli of the solvent or the solution. So we can calculate here the weight of the solute in 450 milli of the solvent by crisscross, so that the weight of the methylene blue will be 480 milli multiplied by 1 gram and divided by 50,000 milli. Then we will get the weight of methylene blue in the given volume, which is 480 milli. Another type of problems in example number 3, let us see that. A pharmacist add 240 milli of aluminum acetate solution containing 5% weight per volume aluminum acetate to 2 liters of water for irrigation. What is the final percentage concentration of aluminum acetate percent? So here in this question he asked about the final concentration after dilution. We make dilution with a solution of 240 milli containing 5% of aluminum acetate. So the concentration before here is 5% and the volume before is 240 milli. And what about the volume after? If we take a 2 liters, it will be wrong. Why? Because we add the 240 milli to the 2 liters. So the final volume will be 2240 milliliters. This is the trick in this problem. The trick here is how to calculate or how to know the final volume. Then if we get the final volume 2240 milli, then complete the calculation by the same way as we learned before. Example number 4, which is also a tricky one and need a highly concentrated person to know what is the given and what he needs from this type of question. A pharmacist is required to produce a liter of sodium chloride solution of such strength that when 20 milli is diluted to 100 milli of water, the resulting concentration will be 0.9%. What is the meaning of that? In this section or in this part of the problem, he said that we have a final solution of volume of 1 liter of sodium chloride. And if we take from this solution 20 milli, then diluted with 100 or diluted to 100 milli with water, we will obtain a concentration of 0.9% weight per volume. So we can put the concentration after is 0.9% and the volume after will be 100 milli. So what is the volume before? The 20 milli that taking from the final solution. So here we can get the concentration before, and this concentration before will be the concentration of the final solution, which is the 1 liter of sodium chloride. By calculation here we can obtain this, and this will be 4.5%. Then the concentration of the 1 liter of sodium chloride, the final solution, will be 4.5%. What is that meaning? It means 4.5% weight per volume means 4.5 grams of sodium chloride in 100 milli of the solution. Let us complete the question here, or the problem here. The only available sodium chloride in the form of tablets, each containing 2.25 grams of sodium chloride. What is the number of tablets required? Here we get the concentration of the solution required, which is 4.5%. And knowing that 4.5 grams dissolved in 1 milli of the solution. So if we have a 1 liter, which is 1000 milli, how many grams of sodium chloride needed? So it can be calculated by crisscross. Then we obtain the weight of the sodium chloride needed to dissolve it in the 1 liter to obtain the final solution. The answer here will be 45 grams. He gives us an information that we have only sodium chloride in the form of tablet, and each tablet contain 2.25 grams sodium chloride, but we need 45 grams sodium chloride. From how many tablets you can get the 45 grams of sodium chloride? It is easy now to calculate this. It will be 20 tablets. The last example in this type of problems, which is example number 5. Here in this question, another type of problem. He said how much diluent must be added. Here he asked about the volume of diluent, not the final volume. So the volume of diluent added to or completed to the final volume. How much diluent must be added to 10 gram of 1 to 100 trituration? So the concentration before will be 1 to 100 trituration. We must give or we must know the meaning of this. 1 to 100 means 1 gram to 100 grams, or that's mean 1% weight per weight. And the volume before would be 10 grams. Okay, we will complete the problem. To make mixture that contain 1 milligram of drug in each 10 gram of final mixture. Here we gives us the concentration, but not directly. He said 1 milligram of the drug in each 10 grams of final mixture. So we must calculate this. 1 milligram in each 10 grams. That's mean 0.001 gram. We convert 1 milligram to grams. It will be 0.001 gram per 10 grams. As we said in the first slide of dilution, the concentration units and volume units must be the same in the both sides of the equation. The concentration before unit will be 1% weight per weight. So the concentration after must be of the same unit, so we must convert it to the same unit. How we will do that? Here we get the 0.001 gram per 10 grams, so we can multiply it by 10 to obtain 0.01 gram per 100 grams. So we here get the percentage 0.01% weight per weight. Here the concentration units becomes of same units, so it will be easy to calculate with the same method using the equation of concentration multiplied by volume before equal concentration multiplied by volume after, and get the final volume after. But here in the question he didn't ask about the volume after. He asked about the volume of the diluent added. Here the volume after will be 1000 gram, and the volume before was 10 grams. So the difference between both will give us the difference or the diluent added to the stock solution to get the final solution. The second part in this lecture is mixing. We will learn now how to deal with those type of problems. First thing, what is the meaning of mixing? Mixing here means the mix of two solid dosage form, either creams, ointment, powders, etc., with two different concentrations to form a new concentration. The new concentration may be more or less than the original concentration. The easiest way is using alligation method. In this method, we will know how to get the final concentration or the first concentration of each content of the mixture by this formula. This formula divided into three parts. The first part is the percentage or concentration of the drug A and drug B. Drug A and drug B may be the same drug but in different concentration. C is the new concentration of the mixture. The second part is the knowing the parts of each content in the mixture. To get that, we subtract the final concentration from the first and the second concentration of the mixture. Let us see an example to show that more easier. In this example number 1, how many grams of 2.5% hydrocortisone cream should be mixed with 360 grams of 0.25% cream to make a 1% hydrocortisone cream? Here we mix 2.5% with 0.25%. So the A will be 2.5% and B will be 0.25%. The final concentration will be 1%, which is C. Here we define A, B, and C. And the weight given here, which one having this weight? He said mixed with 360 grams of 0.25. So it is the weight of B. Here, what is he need from this problem? He need the weight of A, how many grams of A, which is concentration is 2.5%. Here we have the formula. We have A, B, C, and weight of B. The last thing needed, which is weight of A. Here we put each one in its place. 2.5. A will be 2.5, B will be 0.25, and C will be 1%. And second part of alligation is subtraction. 2.5 minus the final concentration will be 1.5, and 0.25 subtracted from 1, this will give us 0.75. This means that we have 0.75 parts of A mixed with 1.5 parts of B to get the final mixture. If we have the weight of B, which is 360 grams, then what is the weight of A? It will be very easy to calculate after this part. Another example here, example number 2. How much urea is required to be added to 64 gram batch of 4% ointment in order to make it 10% strength? He gives us here the percentage or the concentration of A, which is 4%. But he didn't give us the percentage of B, or the second part of the mixture. How can we get this? Here, the final concentration will be 10%. So if the final concentration is more than the first concentration, or the concentration of A, so that the B here will be 100%. And if in any problem the final concentration will be less than the first concentration, and he didn't give us the second concentration of the second part of the mixture, the second concentration we put 0%. We put it as 0%. Okay, so here in this problem, the first concentration A will be 4%, as he said, and we can suppose that B will be 100%. So the final concentration C will be 10%. Here the weight which is given in the problem, which weight? Here 64 gram is the weight of A. So after that it becomes very easy to solve or calculate this problem. A will be 4%, B will be 100%, C will be 10%, and the weight of A will be 64 grams. The final thing is the weight of B, which is needed. For more information about the course of calculation, please contact us on this email and this number. Thank you very much.